Hello, how do you find the value of A in this Oxford or Olympiad maths exam question? We are given the value of 5 to the power of 4 equal to A minus 2 all to the power of 4. If I tell you that this is going to give us 4 solutions, how many of these solutions will be imaginary and how many of these solutions will be real? Join me, let's find out as we solve this. You can pause this video and try it out and then see what your solutions will be like. Now let's solve this. To solve this expression, the first thing I'll do is to take everything probably to the left hand side. And if I take everything to the left hand side, I'm going to have, or to the right hand side, I'm going to have this expression to now give me A minus 2 all to the power of 4. Subtracting 5 to the power of 4 from both sides, I'll have this to be equal to 0. Now, what do I do from here? I'm simply going to simplify. Now, the power of 4 can be equal to 2 multiplied by 2, right? So I can have this expression to give me A minus 2 all to the power of 2, right? And this will be to the power of 2, and this will be minus 5 to the power of 2, and all of these will be to the power of 2, while this will be equal to 0. Now, this looks definitely like an algebraic expression. Now, what is that algebraic expression? From that algebraic expression, you can recall that if you have a square minus b square, what is this going to give us? This is going to give us a minus b, right? And then we'll have a plus b, right? Good. Now from this expression, you can see that my a is simply this and my b is simply this to the square. So if I express that in the way I want to express this, I'm now simply have that expression to now give me all of this. That will now give me a minus 2 square representing a minus 5 square and all of these close brackets, and this will be what? Multiplied by a minus 2 all squared plus 5 squared, and all of this will be closed, and this will be equal to 0. Now this simply gives me something similar to what I call the zero product rule. Now if I separate these two expressions, I'm going to have two distinct expressions. Now what are those expressions? I'm going to have the first expression to give me a minus 2 all squared minus 5 square, and this will be equal to 0. And I'm going to have another solution to give me a minus 2 all squared plus 5 square, and this will be equal to 0. So how do I break down these two expressions in order to have my solutions? Now I can recall this same algebraic expression I used above here. I can still use it for this expression over here. If I use that for this expression, this is simply going to give me a minus 2, right? The first is negative minus 5, right? And that is what this expression will give me. And the other one will give me a minus 2, and this will give me plus 5, right? And all of this will be equal to 0. Using the initial algebraic expression we showed you earlier on, which is absolutely this. Now, applying that over there, we got this. So if we simplify this, we'll have simply this becomes a minus 7, because minus 2 minus 5 will give us minus 7. and then we'll have a plus 3, right? A plus 3, and this will be equal to 0. Now, if we simplify this, you see that our A1 will simply be equal to 7, which is the first solution, the first real solution to that expression, and our A2 will be equal to -3, which seems to be the second solution to that expression given to us. So from this, we have gotten two solutions. We can now find the other two solutions solving the next expression. Now, giving us the next expression, we can solve this next expression for the other value of the other values of a. Now, from this expression now, you can come to see that we can break down this expression. Now, to break down this expression, I want you to recall an algebraic formula. Now, do you recall this algebraic formula, a plus b all squared? You know what this can give us. This will be equal to a square plus b square, recall, and this will be minus 2ab, right? So if we apply it for this expression, we're going to have that expression to now give me a square minus 2 square minus 2 multiplied by a multiplied by 2, right, plus 5 square, and this will be equal to 0. Now, if I simplify that expression, I have that expression to now give me a square. Remember, this is going to be a plus sign, plus 4 minus 4a, and this will be plus 25, while this is equal to 0, right? From the initial expression given to us. So if I simplify this, I'm going to have this expression to now give me a square minus 4a plus 4 plus 25 is going to give me plus 29, and this will be equal to 0. Now look at that expression very well. That expression looks like this algebraic expression, ax squared plus bx plus c equal to 0. So using algebraic formula, we can be able to simplify this. If I use algebraic formula, I'm going to have my a to be equal to 1, my b to be equal to -4, and then my c can be equal to 29. So using the algebraic expression, I have the value of my a to be equal to -b plus or minus the total square root of b squared minus 4ac divided by 2 multiplied by a. Now, using the algebraic expression and inserting the parameters above, we're going to have our a to be equal to negative multiplied by -4, right? And this will be plus or minus the square root of -4 square minus 4 multiplied by 1 multiplied by 29, and this will be all be divided by 2 multiplied by 1. And from that expression, I can see that my a is equal to 4 plus or minus the square root of 4 square is going to give me 16, right? And this is going to give me minus 4 times 29. 4 times 29 is going to give me 116, right? And all of these will be divided by 2. So if I simplify this, I'm going to have my a to be equal to 4 plus or minus square root of, this is going to subtract to give me minus 100, right? And this will be equal to or divided by 2. The value of my a over here can now be equal to 4 plus or minus. I can simplify this to simply give me 10 square multiplied by negative 1, right? And all of these will be divided by 2. If all of this is divided by 2, the value of our a will now be equal to 4 plus or minus square root of 10 square multiplied by square root of negative 1, all divided by 2. Now you know this can be equal to the imaginary according to complex number. So we're going to have a to be equal to 4 plus or minus. That is simply going to give me 10, right? Then j divided by 2. So we'll have that expression. Looking at what is common, we'll have this to be common, and this will give us 2 plus or minus 5 divided by 2. Why 2 cancel out 2? Then the value of our a will now be equal to 2 plus or minus 5 what? J. So from that expression, our A3 can be equal to 2 plus 5J, and then our A4 can be equal to 2 minus 5J. While this is a solution which is complex, this is also a solution which is complex. While the other two solutions are imaginary solutions, which we have seen up there, which is a equal to 7 and a equal to negative 3. So we can absolutely check if our solution is right. Remember, we are given 5 to the power of 4. Can it be equal to a minus 2 to the power of 4? Let's insert the value of a equal to 7 and a equal to minus 3 to see if our solutions is absolutely right. The imaginary remains imaginary solution. So if we are given 5 to the power of 4, can this be equal to a minus 2, right? All to the power of 4 at a equal to 7. Let's find out. If a is equal to 7, then this solution will be 5 to the power of 4. 5 to the power of 4, can it be equal to 7 minus 2 to the power of 4? Then 5 to the power of 4 will be equal to 7 minus 2 is 5 to the power of 4. So this solution is absolutely what? Correct. What if our a is equal to negative 3? Now let's try that. We'll have 5 to the power of 4 equal to negative 3. We'll have negative 3 minus 2. Will it be equal to this? Let's find out. 5 to the power of 4 is equal to negative 5 to the power of 4. It looks as if it's not same, but let's simplify further. We'll have this to be 5 to the power of 2. If we simplify this, separate this according to the law of indices, this can also be separated, and then we'll have 5 to the power of 2, and all of these will be to the power of 2. 5 to the power of 2 will simply give us 25 what? Square, and this will be equal to negative 5 square is going to give us 25, and all what? All squared. So this is simply equal to this, which simply tells us that the value of a equal to 3 is a solution that is also what? Correct. So two real solutions, two imaginary solutions, which are absolutely right for this expression given to us up there. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified math content. Thanks so much for watching, and bye bye for now.